In this chapter, I'm going to show you what it takes to create custom static meshes in Unreal. Now, if you're not interested in doing that, if you haven't used Maya or Max or XSI, it's probably still worth watching the first 10 minutes or so of this video, of this chapter, because I'll show a couple useful tools for navigating the world and seeing how it's put together, and I'll also show you how to create your first packet. And then once I get into the Maya section, you can skip forward. But that said, let's take a look at how the world is put together. I'm in the DM Sanctuary map here. You've probably poked around in it at least a little by this point. But the first main thing to notice is how much meshes are reused in the scene. All of these columns are the same mesh. These little detail pieces here are the same. Each of these staircases are the same. It's really amazing how much coverage they've gotten just by using the same meshes again and again. And we can get a better picture of that. If you right-click on a mesh, we can select all instances of that mesh in the world. So right-click, select Actors, select Matching Static Meshes, this class. And you can see it's used everywhere. And if you look at the bottom of the window, it'll tell you 127 static mesh actors selected. So this column is used 127 times. And say I select one of these little railing pieces, select matching static meshes, that one's used 157 times, and that's cloned all over the place. So that can be a pretty good way to see, if you see something that looks like it'd be a common object, see where else it's used. But there's another tool we can use to visualize this, and that's called the Primitive Stats Browser. I'm going to open the Content Browser, and then it's one of the other tabs at the top, towards the right, Primitive Stats. Now, if you click on the Count column up at the top, what that'll do is it'll sort. This is all the meshes that are used in the world, and that'll sort it by which meshes are used most frequently. And if I double click on this top one, it's used 207 times, and you can see in the level, if I go inside, it's this sort of ornate detail piece. And I can select just one of them, and you can see it's just this sort of ridged archway that got cloned again and again and pieced together into these really interesting arrangements. If I select this, that's this sort of column cap piece. You can go through at your own pace, but definitely see the world is put together from some really simple assets that are just used again and again. Now, one other interesting thing, I can sort by count again, and then I can see what's used only once. And you'll note there's probably only 24 assets that were only used one time in the level. Everything else was used at least twice, if not more. So it really gives you a look at how powerful the modularity is in a tool like Unreal. Now, why that's important is, first and foremost, it saves a ton of memory. If I've only got a couple hundred meshes, source meshes used in the scene, that doesn't take up a lot of memory. Every time I place a new instance, there's a tiny little bit of overhead for its position information, but all of that polygon detail, all the materials and textures, I only need to count that once. So we can get a whole lot more ornate detail in the scene for a very small amount of memory. It also saves a ton of time for the artist. If you only have to build one column prop, and you can put a ton of detail into it, really polish the textures and the materials and the mesh until they look really good, then all of that polished detail, you see the benefit of that for every single column that's placed in the world. And if you take that mentality forward, you can get a much more elaborate scene just by detailing out a few pieces than if you could if everything in the world was unique. So if I hide all of the static meshes, like we saw at the beginning of this DVD, anything that's left is the custom architectural detail of the world. And this is all left in BSP and terrain. The artists at Epic haven't gone and modeled any of this as static meshes. BSP and terrain, well, BSP is a little bit more expensive, but for the workflow, it's really worth it to keep custom architectural detail built in-game like this, rather than going and modeling it in Maya or Max. If you have to make a change, it's really super easy to do. You don't have to go find the source asset. It just works out a lot better. Now that said, the art style of Unreal Tournament and of Gears of War really lends itself well to that. might not work for all games. For instance, on my last game, we had an Italian village where all of the architecture was this very organic geometry. All the buildings were these really worn and weathered, rounded surfaces. So each building kind of had to be just a single static mesh with doors and windows and things were individual meshes, but the building as a whole was one mesh. But that said, at least we could clone stamp those buildings around, use them more than one time in the level, and get some memory savings and get some benefit from the reuse of the assets that way. So spend some time poking around in the level if you haven't already, really get a sense for how it was put together, and hopefully that'll inspire you as you're creating your own assets to find ways to build them in a modular fashion so that you can get the best use of memory and make the best use of your time. Before we create our own custom meshes, we need to first understand how packages work. So everything we've placed so far has been a static mesh or a material that was in a package that somebody at Epic already created. So we need to create our own. So before we go through the whole mesh process, let me show you how to do that really simply using a test material. Now there's no such thing as an empty package in Unreal. The way you create a package is by creating an asset. So I'm going to right-click somewhere in the blank space between these icons, and I'm going to choose New Material. And this is going to just kind of be a placeholder for us. So New Material, let's give the package a name. So this is going to be Custom Asset Test 01. And let's make this material just a really bright, obvious green. So let's call it Green Matte. And I'm going to hit OK. So a material editor has opened up. I'm going to close that for now. And in the content browser, you'll notice that there's a new folder under packages called New Packages. And this is just kind of a handy shortcut for any packages that you've created that you've been working with lately. So first thing let's save this to disk. I'm going to right-click Save. And now I can choose where it's going to go. So let's put it let's put it inside the Gnomon DVD folder. And don't change the file name. Just leave it so that it matches exactly what the file name was inside of Unreal. All right, now I'm going to go back to our test map, BSP Room 04. Now let's modify this material so that it's that green color that matches the name, and then we'll apply it to a wall to see how that works. So I'm going to double click on it. Now we'll go over the material editor in a little bit more detail a little bit later on. For now, this left-hand viewport is your material preview, but we don't have anything plugged in yet, which is why it's showing up black. And this viewport in the middle is where we create our node network that describes how the material looks. So without going into too much detail, this box on the right is material expressions. This is how we construct our material. I'm going to scroll all the way to the top. There's, under the constants field, there's something called a constant 3 vector. The number 3 is important because it allows us to plug in an RGB value. So I'm going to click and drag one of those into the viewport. If you need to move the view around, you can control left-click drag, or I'm sorry, just left-click drag. And if you need to move one of these nodes around, you can control left-click drag that. Now what we want to do is make this green. So if you have it selected at the bottom of the window, you can see the properties for it. Red, green, blue. I'm going to type in a number 1 for green, which essentially means 100% bright. Now we still need to connect it up to our material. So the color node has this little black dot on the left-hand side of it. I'm going to click and drag a line from that to the input for where it says diffuse. Diffuse meaning this is what's going to take diffuse lighting. And now our material preview shows up green, it's taking lighting, and it's all good. So to apply those changes, just click on the little green check mark at the top of the window, close the material, and you'll see that the material preview in the package is showing up green. So exactly what we wanted. So now I can save the package, and let's apply this to a wall inside of our room. Or actually, let's make it the ceiling here. So I got the material selected, and I'm going to alt-click on the ceiling. And if I deselect, you can see that it's that bright green color. So we didn't have to make a placeholder material. We could have imported our mesh directly into this package, but it's just a handy way to demonstrate how to go about creating a packet. Oh, I guess one last thing. In the content browser, so obviously it's showing up under new packages, but I can also browse to it using the folder structure, num and dvd, and there we go. There's our custom asset test package, and there's our material. For this demonstration of how to create a custom static mesh, I'm not going to assume anything about which software package you're using for the 3D side. It could be Maya, Max, XSI. Really, this is more about how it interfaces with Unreal. So I'll assume you know how to model and stuff in whatever software you're using, and we'll just go over how it interfaces with Unreal. So first things first, we'll need to set up the exporter. Now that does ship with the UDK, so that's in the UDK folder, binaries, and then actor X is the name of the exporter. And you can pick whichever version matches the software that you're using. And I'll assume that you know how to install a plugin for your software. So let's skip over to Maya. I've already set everything up and it's ready to go. So let's start by creating just a simple mesh, just a sphere. So click and drag, looks pretty good. The command to export from Maya is axmesh, xmesh, which brings up this interface, and I've already created myself a shelf icon for it. If you're in Max, or I believe XSI, it's just you go to File, Export, and then it'll be one of the file types. ASE is what you're looking for. So we'll bring up the export. I've already picked the properties I want, but usually I choose selected items only, auto triangulate, and obey hard edges. Kind of personal preference, but just use those as a starting point. And if you dig in more, figure out what more of the settings mean, you can use those. Well, that's up to you. So export mesh. Now, what we're going to export is kind of an intermediate file. It's not something that we need to keep around, so I'll put it on my desktop, and let's just call it sphere.ase. Now let's go back to Unreal. I've got my package selected, and I'll hit the import button in the bottom left-hand corner and choose that sphere ASE file that I saved onto my desktop. This is a pretty standard import dialog. You want to make sure that the package is actually the correct package that you want to import into. It'll default to whatever you have selected. And then it'll fill the name in automatically based on the file name on disk. Well, obviously we called it sphere.ase, so it filled in sphere. And you shouldn't have to worry about the rest of these options. So just hit OK. And there we go. A new mesh got imported into the package, and if you double click on it, open up the static mesh editor. Don't have any materials applied to it yet, but it's basically what we wanted. So now with that selected, I can hold S and click to place it in the scene. May seem a little bit small, but it's basically there. So I could fix the scale by scaling up the object in the world, but that's not ideal because every time I place one of these spheres, I'm going to need to scale it up again. Better to fix it at the source in the Maya file. Now, as we discussed earlier, scale in Unreal is 16 units per foot, and a character is about 88 units tall. Ultimately, what it comes down to is, in Maya at least, the scale is in centimeters, and then 1 centimeter translates to 1 Unreal unit, and you kind of don't want to have to do that math every time. So what I do when I'm working is I create a either I create a human-shaped mesh, like I'll bring in one of the characters and use it for visual scale reference, or I'll just create a box that's about the right dimensions, 88 units tall, and I'll place that in my scene, or I'll place that next to my object so that I can be sure I'm building to the right scale. Ultimately, real-world scale is kind of out the door anyway. The character can run like 20, 30 miles an hour, and so everything seems way smaller in a game world than it does in the real world anyway. So ultimately, you just have to get it into the game, eyeball it next to its neighbors, and make sure the scale looks correct. But that said, let's get this sphere so that it's 88 units tall. I'll select properties. So if the total height is 88 units, the radius has to be 44. So that's much bigger. Let's re-export. I'll save over that same ASE file. Go back to Unreal. Now I could hit import again, browse to the file, and overwrite this one, but there's a shortcut. I can right-click on it, and the third option down is re-import static mesh. And what that does is it goes back to that ASC file and re-imports it over the top of what I've got. And as soon as I update the 3D viewport, you can see the sphere got bigger. So one problem solved, but let's deal with a pivot. Right now it's in the center of the mesh, which actually for a sphere might be okay. But let's say we wanted to get it at the bottom of the mesh so that every time we place one of these in the world, it's sitting properly on the floor rather than sinking through it. If I go back to Maya, the origin of the mesh, once it gets into Unreal, or rather the pivot of the mesh, is going to be the origin in Maya. So all I need to do is go into one of the side views and move it up so that the very bottom of the sphere is sitting at the origin. Now, if I export, switch back to Unreal, re-import, and there we go. Now the sphere is sitting properly on the ground. So let's look at how to get a material onto this sphere. I'll double click on it to open it up. And where that parameter lives is under LOD info, 0, element, 0, and then there's a property here called material. Or of course the shortcut is you can search for the keyword material, or just mat is enough. And then I can select, for instance, this green material. Now this is a pretty common interface option, but wherever there's a plugin for a different object, you'll see this little green arrow. And what that does, whatever you have selected in the content browser, it'll plug that in. So if I click on that, my sphere turns green, and every instance in the world turns green as well. And I could take any material. So select one of the walls and find in content browser, and then I can plug that in. And then all of the spheres will be textured with that wall. And one other cool shortcut, if you select something in the content browser, sorry, I'm a little off the screen there. If you select something in the content browser and hit Control-C to copy it, you can then select this text string and hit Control-V to paste. Those are the standard Windows hotkeys for copy and paste. And then when you hit Enter, whatever you copied and pasted into there will also show up on the object. And again, that's pretty common and works pretty much anywhere inside of Unreal. So not much more there. Let's go down and save the package. It should refresh. Yeah, as soon as I click on it, it refreshes. So I'll save that. Keep in mind, saving your package is really, really important, and it's really easy to forget to do early on. If you don't save your package and you place your mesh multiple places in the world, and you save your map but forget to save your package, what's going to happen is when you restart Unreal, your mesh is just going to be gone. It's not going to be in the package, and none of the placement in the world is going to work anymore. So be really super careful about that. Anytime you make a change, you always save your package. All right, so I've baked lighting. Now, if I play this in the level, what's going to happen is I'll be able to pass right through any of these objects. They don't have any collision geometry on them yet. So let's look at how to add that. I'm going to sync content browser, or I'll just hit the shortcut, Control-B, open up the mesh. Now we can add collision from this menu here. Collision, lots of different options, but let's choose the first one. 6DOP simplified collision. Basically it's going to make a box that surrounds it. And I can click on this icon, the one with a red border around it, to show collision. So there we go. It's a box that surrounds the mesh. And if I play that in the level, now I can no longer run through these spheres. It may seem a little bit weird, like I can't get any closer to it than this, but you'd be surprised at what the player actually notices in the middle of a real game. It's really all about player perception, so yeah, maybe I feel like I'm getting caught on the corners here, but for the most part I can't tell that this sphere doesn't have exact perfect collision. But let's look at how to get it a little bit more close than that. If I go turn it on again, I'll go to the collision menu. Now these next three options are essentially cylinder collision, oriented in different directions. So if I choose X, yes, I want to replace. You can see it's sort of a octagonal cylinder. Or I can choose the Z-oriented one. And there we go, now we have a vertical cylinder. So if I try that out, there we go. I pretty much can't tell that the collision doesn't fit the sphere perfectly. And even if I jump on top of it, I can't tell that I'm standing on a cylinder and not a sphere. So something like that is a really good balance where it's not super detailed, but just detailed enough to fool the player. That's really the ideal with collision. So we can go more precise. I can go to 18 or 26 sided. This is kind of overkill. Each polygon that makes up the collision geometry does cost performance, so this will be more expensive at runtime than using the cylinder would be. I've also got a tool for auto-convex collision, which it's almost like a shrink wrap tool. I'm not going to go too much into the settings here. Essentially, drag the slider left is simpler, drag it right is more complicated. But the defaults for this one, you can tell it's a really nice snug fit. Actually, it's inside of a lot of the polygons. I can go to wireframe mode here, and maybe that's harder to see. Tell you what, I'll fly the camera inside of the mesh, and you can see that it's actually made up of a ton of different collision primitives now. Each color means it's a different primitive, and each one is really tessellated. So this is probably way overkill, but it's almost polygon perfect geometry. But it's going to be really expensive, not only because of the number of polygons used, but if you look here, it says num primitives 10. That's the main thing that you want to make sure is as low as possible while still giving you the gameplay that you need. So I'm going to go back to 10-sided, and for now, we'll leave it at that. For a lot of meshes, those auto collision generation tools work just fine. But in some cases, you'll need to model the collision by hand. Say if you've got a doorway or something that's an arch shape, you're not going to be able to auto-generate collision for that. So let's look at how to do that. If I go back to Maya, really all I need to do is create whatever mesh shape that I need. So I'm going to create just a simple box that surrounds the sphere. I'm not going to be really precise here, but obviously you can put as much time and detail into it as you need. Alright, so I've got a box. Now what I need to do is tell Unreal somehow that one of these meshes is going to be my renderable mesh and one of them is my collision mesh. And that's really easy. It's just through the naming conventions. So I've got my sphere and I've got my cube. The cube is the collision mesh. So let's rename it. At the end of the name, I'm going to put an underscore and then UCX, all in capital. Now if I select those, export, overwrite the sphere, OK. Switch back to Unreal and right-click, re-import. What we got, if you show collision, is that box that I created inside of Maya. So, simple as that. So there's a couple things to watch out for when creating your own custom collision geo. First off, the mesh has to be a closed mesh. If you delete one of the faces, it just won't work. So don't do that. The next thing to remember is that the collision geometry has to be convex. It can't have any sections that go inward. You can see in this illustration, even though this isn't a square, it's kind of this odd trapezoid shape. The image on the left would be just fine, but the shape I've drawn on the right would cause problems in Unreal. It's not the end of the world. Unreal would deal with it pretty well. It would chop it up, but it would become two separate meshes, and that wastes frame rate when it comes down to it. The thing to look for, again, like we saw earlier, just visualize the collision once you've imported your mesh and look at the num primitives option on the left-hand side here. and make sure that what came in is exactly what you intended. So next thing to watch out for is you can make your collision out of multiple primitives, just make sure you don't overlap them. So if you're making, well, obviously like an L-shaped piece here, or if you needed to make a like an archway out of 3 collision primitives, that's no big deal. Just make sure that they don't overlap. And inside of your 3D package, you can either merge them all into the same mesh or keep them as 3 separate meshes, all named _UCX. Either one will work just fine. So let's look at some examples of what that looks like on a mesh. I'm going to filter by static meshes, and I'm going to look for door 04. You can tell I found this one earlier. So it's a simple archway mesh, and if I show collision, you can see it's made up of 3 pieces, cut very close to each other. None of them are perfect squares. Obviously, they're all sort of angled inward, and they're actually molded to fit pretty closely to the visible geometry. But because they're separate, and because none of these 3 primitives have any concave areas, Unreal can handle it just fine. So one other example I'd like to show, I'm going to search for rubble 4, and if I show collision on that one, you can see it's just a single primitive, but it's kind of this blobby, lumpy shape that more or less encompasses the whole mesh. Then this is perfectly fine too. As long as the entire thing is convex, as long as none of these triangles go inward, Unreal will handle it just fine. So I'll show you one other option. Now you won't normally need to use this. Generally it'll cause a big performance hit if you use it in the wrong place. But there are some situations where you just can't model proper collision geometry for an object. So for instance, if you have to make a ground plane, or like I was talking about earlier, those houses for the Italian village, if I was going to model simple collision geometry for those, it would have been 40 collision primitives for the entire house. So in that case, it's better to use per poly collision. And the way you can do that is to uncheck these 3 check marks. So by saying, well, simple collision is the collision we imported from Maya, so unchecking that means we use per poly. Again, be really, really careful about that. But if you're making a building that's relatively low poly but would require a lot of collision primitives, or you're making something that is a terrain piece that the player needs to walk on, sometimes this is your only option. But again, be super careful about that, and if you can, create collision geo either here or in Maya. So there are a couple other properties of static meshes that you probably need to know how they work if you're creating your own custom meshes. First is that, yes, you can apply more than one material to a mesh. I'm going to search for one that I know has it, light concave. You can see here there's a middle section. This glowing white section is one material that's emissive, and then the surrounding area, the middle part, is a separate material. And if I dig into the LOD info, you can see it's got 2 slots, 0 and 1, and it's got a different material applied in each of those. So that's really easy to set up. In Maya, just apply a separate material to whichever polygons you need to apply them to. In Max, create a multi-sub-object material and set however many slots you need. But be cautious. If you go to the primitive stats browser, one of the columns, the second column, is labeled sections. And what that means is, essentially, for each material that's applied to a mesh, it has to be sent to the video card a separate time. So if a mesh has 2 sections, it's essentially as expensive as 2 meshes. If it's got 10 sections, it's almost like having 10 meshes in the level. So if you've got a special case, like a one-off, like a statue or something, and you're only using it a handful of times in the level, not that big of a deal. But if we took those trim pieces, or something that we saw in Sanctuary that are used hundreds of times, you want to definitely make sure those only use 1 section, Otherwise, their cost is doubled or tripled when it comes to rendering. Let's see. So next, smoothing groups or hard and soft edges do come across into Unreal. You can see again with this mesh, all these edges are hard and all these interior edges are soft. So spend some time, set those up, and make sure your object looks good as far as edges goes, and that'll come across properly in Unreal. Next is the question of normals. Unreal doesn't support two-sided faces by default. That's true of most real-time renderers because it does cost more frame rate to render the backsides of things. So if I go inside of the sphere, you can see it's hollow, it just disappears. So make sure when you're modeling in Maya or Max or whatever, either you've turned on backface culling or you preview the normals of your mesh before you bring it in. Otherwise, certain parts of your mesh may appear inside out. And to fix it, you'll either have to unify the normals or flip the normals. So just be aware of that. Don't expect that you're going to get two-sided polygons. You can in special cases. For instance, if you're doing foliage or something with transparency, it might make sense to turn that on. But 99% of the time, you won't want to use that because it's much more expensive. Next, LODs. Unreal does support LODs, but they're not really common in Gears of War or Unreal Tournament 3, just because of the nature of the environments that are set up. There tend to be a lot more close quarters, and really that's not where the rendering cost is going. But depending on the game engine you're working on, you may need to generate them. So Unreal does have a tool to auto-generate. It's under Mesh, Generate LOD. You can play with that if you need to. Or you can model a separate LOD in Maya, save it out as a separate ASE file, and then go to Mesh, Import Mesh LOD, and then you can choose which LOD level it is. I'm not going to go into too much detail because you shouldn't really need it if you're working on something similar to Unreal or Gears, but know that the option is there if you need it. As far as UV mapping goes, nothing special. It's okay to go outside of 0 to 1 space. It's okay to have overlapping UVs, especially for the primary UV set. But as we saw, Unreal really likes to be able to do custom light map UVs for when we bake our lighting. So I'm going to go into this mode. I'm going to show UV overlay. I can model my second UV set in Maya if I need to. It'll definitely turn out better and save me some UV space. I can do that by going to create UVs and then create empty UV set, and then I can choose the UV set I want here, and then essentially I can model the UVs however I want. Or I can generate it in Unreal. Mesh, generate unique UVs. Generally you have to make the window a little bit bigger to see all the options. But we want to generate LOD1, and then you can play with these settings to get the results you want. But as soon as I hit apply, there we go. It's unwrapped my object, and now I'll be able to generate proper light maps on it. If you don't generate unique UVs, it's going to use vertex lighting, which in a lot of ways takes up a lot more memory and very often doesn't look as good. So I recommend always generating light map UVs either in Unreal or make them yourself in your 3D package. So that's about it for options that come across in a static mesh. With that, let's move on to materials and textures.